So essentially, and I'm not going to read this verbatim, we have a breach. A company's been breached. DeceptiTech has been breached. They have a specialized honeypot development and deception technologies. At the heart of their success are called DeceptiPots. So, honeypots, some of you may have been following other content creators that are encouraging you to do honeypots. This is kind of a flare of that. I don't encourage you to set up a honeypot personally, but do you, boo? This is just something interesting. It does take a lot of time to do it right. So that's why I say don't do it, but whatever. In this case, this is important that we need to look at kind of the layout. And I encourage you to understand any of these problems, seek to understand what you're looking at. And what we're looking at is kind of a hybrid type environment here. We have a little bit of AWS, we have remote users, and then we have the corporate network. So this is pretty common to most companies these days, right? We got some stuff in the cloud, we got some stuff on site, and then we have remote employees everywhere, except for those that got forced to go back into office. Those are on the corporate network. Hopefully, that's no one here. Um, yeah, so very important to kind of understand because as we're analyzing the attack, it helps give us perspective as we're building that narrative out, right? Okay, so one ordinary morning, the entire network has collapsed. Uh oh, right? And all the critical on premise systems are now locked down and encrypted. Sounds like we got some ransomware here. They're hurrying to restore backups. They rush to the SIM only to find backups are corrupted. All the SIM data is wiped clean. So, this is a pretty common scenario with ransomware in general. And I've actually had some interviews recently where they're asking a lot about ransomware type stuff. So, this is very common. Things get wiped in, especially the smaller businesses where they don't have SIMs, they don't have a lot of security tools and all of that. Those are things that are pretty common. Now, this room is all about the first attack stage. So, this is a multi room thing. So, maybe we'll continue on if they look to be something cool that I think the viewers and the members here will get a lot out of. We'll do some more. This one for sure is good though. And as part of an external D for a team. So, this is forensics, incident response type team. Can you help them perform a full scope investigation and explain how the attack started? Now, this question is exactly why I picked this to do live. There's a lot to unpack here, a lot of things, a lot of insight that many of you don't have if you haven't actually done work in an industry yet. So, this is a chance for you to get that insight. What does someone actually do if there is an incident? What does a member of the incident response team do? All those types of things. And yeah, hopefully you learn a few things. So let's get started. We'll go ahead and check the box here and we'll move on to the meat of this. Oh, I thought it was already set up. We'll start the machine. Configured, replicate. So there is a WordPress blog here. It's exposed to the internet and they want to see what it captures over the weekend. Little does she know, threat actors around the globe enjoy testing the DeceptiPot 2. Can you find out how the attack started? So essentially, a website got taken over and they took control of a Linux system. Our job is to actually follow the path of this attack from how did they get in, how do they set up persistence, and what does that look like? So, legitimately, a real attack here, a real attack chain, real um, real processes that an incident responder may do. All of that will be real. And one of the things we'll make sure to do on this stream is we'll try to write the narrative. So this is something that you would have to do during an incident is you got to tell the story of what happened in the order of things that happened. And this is going to do a lot. One, it's going to help you make a case for why you should have a job, right? You got breached. You need to be able to rescue them. Why do you have a job? So your executives will know, you know what you're doing. You're doing a good job. And then two, you need to figure out where your weaknesses are in your environment. So if you miss a spot, you won't be able to fix that. And someone may be able to jump right back through the same hole. Three, you really need to see the origins and make sure you get them completely out of the environment as well, right? If you miss one tiny thing, they're going to be right back in your environment. You're going to have to start your incident response process all over. So you have to be very deliberate and you have to follow the clues like a real police detective. All right, looks like we are good to go here. All right, so we are going to log into the host via SSH. And then we are going to start chipping away at these answers here. So we're going to say SSH, Ubuntu, and then I'm going to do a Control Shift to actually paste the address. Yes. Oops. I didn't type it wrong. Let me get rid of this little stupid thing on my screen. I don't think you can see it, but I can see it. And I think it's just secure exclamation mark. Maybe. Might have typed it in wrong. Nope, it was right. Okay. Now we're in, we have access. Let's look at what we need to do first. So it says, which web page did the attacker attempt to brute force? So as we're going through each one of these questions, I want you to start practicing, and I need to get this a little bit closer. Let me push this over. All right, there we go. Just a setup here. I want you to think about, where could I find this information? What do I need to do to be able to look at that information so I can make a decision? And then also, what would this look like in the evidence I'm looking at? So, three major questions there. And there's a lot more to it than it first sounds like, right? So, for instance, which web page did the attacker attempt to brute force? Well, in a lot of cases, in most organizations, we may look at a WAF. That's pretty common where you'd be able to see the traffic, but there are other places as well to find that. So there are going to be specific web application logs on the local host. So we are SSH'd into the web server itself. So there should be web application logs there. Now, there are typically two types. We have typically access logs and then authentication logs, and there may be some other logs as well, but those are your two major ones typically. Authentication is who's logging in. And then access logs is what are they accessing? So not just whoever's logged in, but any user, any person, what are they accessing on the website? And guess what? That is exactly what we need to go to see which web page did the attacker attempt to brute force, because we should be able to see evidence of brute forcing somewhere in that. So let's go ahead and grab those logs. I'm actually going to pull them down once we find them and throw them into Log Viewer over here, because it's a little bit cleaner than looking at them in the command line. And typically we would have tools to pull logs out and look at and be able to filter and do some fun magic with them. So let's find them, and then we will look at them. All right, so the question is, where would these logs live? If anyone's familiar with Linux, you should pretty much know they live in var, right? So if we say we'll cd in there, we'll cd/var log. And we can look in here and we can see all kinds of logs. Now, these aren't going to be only the web application logs. These are going to be all the logs for this host. Now, we don't want to look at all of these, right? During an incident, we only have so much time to do the investigation. And we're also actively, essentially fighting the bad guy, right? So we need to move faster than the bad guy so that we can actually get the system to a good space. So we probably should have already cut off access by now, but just something to think about. Now, looking through this list, there's a bunch of different options here. But one thing that should stand out to you is the Apache 2 directory. So, Apache 2 is a type of web server. And this is indeed the question that we were asked, which is which web page? So, we're looking for a web server, and this is very much likely that web server. So, if we just ls Apache, oh, is there no, there we go. I was going to say, is there no tab complete? When we look in here, we see exactly what I was talking about. We do see access logs, we see error logs, we don't see authentication logs. We see some higher up in the hierarchy here, but we do see access logs. So let's do a tell on access logs. Actually, we may need to do a cat and then tell. Cat access logs. Oh, wrong directory. Silly me. Apache 2, there we go. All right, now we'll do tell access log. And I do tell because we don't want to look at all of them yet. We want to look at just a sample to see if this is indeed what we're looking for. And we do see some indications that this is indeed what we're looking for. We see a GET request here to a PHP file with a 404. We see some user agents here. We see another directory and file here. So we see a lot. We see some funky hex here, password. So we're seeing stuff indicative of a legitimately application that's running, right? So we do see that. So these are the logs that we want. Now we just need to pull these down, and I could pull this from my list of commands. I don't memorize a ton of commands because I'm lazy, but we can have Google AI help us figure it out. So we can say, use SCP to pull a file down, file from remote server. Yep. And so this is going to give us the syntax we're going to need for this, and we'll just build it out like I typically do. And then we'll just copy and paste it on into our terminal. So here we go. Copy right here. We'll paste this. And what we'll need is we'll need an IP address for sure. And that is right here. We'll use this. So this will be the destination address right here. And so we'll put that there. And then this is our username that we use to connect. So basically, excuse me, wow, I can't talk. Basically, this is SSH, but for file transfer. So it's a secure copy. So we're using essentially SSH to log into the system, pull a file. So pretty straightforward. And it does it securely. So it's not like FTP where you could actually see the traffic. This is all secure. So path to remote file. So this is going to be /var log. And I think it was Apache 2. We'll just look at this real quick. Yep, Apache 2 lowercase, and then we'll need access log. We'll pull this real quick. Hello, if you're just joining us, say hello in chat. What brought you here today? And we'll go ahead and remove this. And we're just going to do a /. So wherever we run this at, whatever directory we run this at, it's going to pull it down into there. But saying that, we need to go ahead and prep a directory to do this. So I'm just going to do a, let's see, make dir decept stream cd decept stream. So I'm just using tab complete if you're wondering, how is Mike able to do that so fast? Just like that. All right, so now we'll just copy this, and the file should pull it right into there. We'll prompt us for a password. We type it in, and it'll pull it down. So if we ls, we do have our access logs now. So all we did was pull them down to our host, and now we're going to put them into this website here. I definitely don't encourage you to do this in a real investigation. You should have your own tools. You should have a SIM that you could do this in. Just want to put that out there. Let's see. These are the ones we pulled, and they're in here. So let's make them. Let's see. Can I not maneuver this any? Okay. All right. All right. So I'm going to get you oriented first. Then we'll look and see if we can't find some of this brute forcing. So we're looking for brute forcing is what we're looking for here. All right. So all of our access logs pretty much have the same structure. So anytime we talk about logs, we talk about a structure for logs. Linux logs will always look, not always, Linux logs will usually look pretty much like this, where you have a source, a date somewhere in there, and then the actual information. They're usually structured pretty much the same. And this is where all the information is. Because these are web logs, we have the source of the request. So this is the actual IP of the user interacting with the site. This is the time. So the exact time. This is going to help us with our narrative. This is the type of request. So, right, we have get, options, head, post. We see all these down here, all these different types. That's what that second piece is. This is going to be, what are they accessing, right? So is it /home /index? What is it? What are they accessing it? That's what follows the type of HTTP request. And then, of course, anything that's used as a parameter will follow it as well. So this one actually has one. So, right, if you're not familiar with web stuff, the question mark is saying, hey, everything after this is going to be parameters. And they're usually done by like a key value. Lots of fun words for you folks today. Some good vocabulary. Okay, and let's see what else. And some other interesting things here are the user agent. So you've probably heard the term user agent before, and this is usually indicative of what type of thing is accessing the web resource. And when I say web resource, I mean website, picture, whatever it is on the website that the item's accessing. This is going to tell you a little bit about it. Now, can it be changed? Absolutely. We can make our user agent be whatever we want it to be. But for most users, so 99.9999% of users, it's going to be the thing that is making the request. So is it your browser like Mozilla, Firefox, whatever, Chrome, whatever? Or is it your phone? Is it a specific type of Python tool? Whatever it is, it will likely be in here. Again, attackers can make it do whatever they want, but this is going to be pretty indicative of the thing accessing it. And typically, I will say this is one of the IOCs I like to key in on if I'm actually investigating a real attack, because typically the attacker will use the same user agent for all of their attacks, and it's usually unique enough for me to search logs for. So even if they're changing IP addresses, which happens quite a bit, the user agent typically stays the same. Just putting that out there. So when I look at stuff, I look at IOCs and I'm thinking, what can I search on here that is going to help me find the bad guy, find their activity? Okay, so any questions on that, drop them in chat and I'll answer them. But until then, we'll keep chugging along here. And you can see different user agents here too, right? Look at that, Macintosh. So that's what I mean. All right, so we don't really care about the IP address yet. We're looking for brute forcing activity, meaning we should see similar things repeated over and over. That would be brute forcing. And then if we look at the same IP, it should be the same IP doing all that hard work. So we can just scroll through here and look. So this would be something that I would consider brute forcing, right? A lot of get, post, all the same thing, all the same user agent, all the same IP address. So This is very much the brute forcing we're looking at. Now, when I mentioned earlier that the user agent is typically going to be the same, this is a very unique user agent, and it's Hydra. Hydra is a brute forcing tool, and it's probably installed on this Kali system itself. Like we can look right now and say Hydra. Look at that. It's installed in Kali. So you could see all kind of stuff, right? And again, they could have created a custom user agent if they wanted, but they didn't. So it is what it is. All right, so we'll just continue to look through this. I don't know why it keeps shifting on us here, but it does, whatever. So we got lots and lots and lots and lots of guesses. This is indeed brute forcing, right? All right, so let's go back and look at the question so we can answer it. And the question is, which web page did the attacker attempt to brute force? Now, something to point out here is that we actually do not see the values of the post requests. So typically, what you'll see when you access, say, like a login, right? The get will be, get this page. Let me see the login form itself. And then when we submit information to the login form, that's going to be a post more than likely. And the post is just saying, hey, I'm submitting a form, and then it's going to do whatever it's going to do on the back end, which is validate that user. So that's why we're seeing a mix of get and post here, is because that's how it works. Now, the page that we're targeting, the other point I was going to drive home is we don't see the value of the post request. This log isn't going to tell you that. We would have to acquire other logs for that. We would probably see them in a WAF if we had them. So, something to think about. We don't have all the tools we normally have. Sorry, I paused to see someone chatted in. Chat. I'll throw that on the stream. What do you mean every time you attempt to do something with Ubuntu, it's down? Is like the website itself down so you can't pull it down? Or what's going on with you, Hunted? All right, so let's go ahead and copy this. And this should be our, if it'll let me, it might not let me. This should be our answer. There we go. Check. All right. First one, pretty easy, right? All right. Now comes a hard one. What is the absolute path to the backdoored PHP file? So let's get oriented before we dive into this one. This one is going to be a little bit of a wild ride. So hang in there. All right. So when we're reading this, actually, let me go back to it. When we're reading this, right, again, I want you to be processing this information in your mind. What is the absolute path to the backdoor PHP file? We've got a couple of nuggets of information. We know a PHP file has been backdoored. So that kind of narrows down all the files, because there's a lot of files we haven't even looked at. We haven't looked at the files for the web server. There's going to be a ton. So this narrows it down to specific PHP files. And we know it's backdoored. So there should be some kind of malicious code somewhere. Now, there's lots of different types of backdoors, but we could probably look one up and see, let's see, PHP shell pen test. And we can get some familiarization with what does it look like? And this is indeed what it looks like. If you have a command shell on a PHP file, this is what it's going to look like. And there's tons of variations. It can get infinitely more complicated than this pretty quickly. But what we're trying to understand, and what a lot of SOC analysts fail to do, is understand the attack before they start investigating. I have seen this my entire career. Analysts just dive right in, and they're just playing whack-a-mole, just running into a dark room. They have no clue what they're looking for, but they're looking for something. And what it results in is you not finding anything, or luckily finding stuff, right? You just happen to trip over something and you found something bad. The difference between a junior analyst and a more senior analyst is that you're a lot more surgical. You have an idea of what you're looking for, and it's really theory-based, hypothesis-driven approach, kind of like Hunt's, if you've ever looked into that career. So it's hypothesis driven, which means I know what I'm looking for. I know what the variations are. I know where to look for it, and I'm diving in. Or I'm going to answer those questions first before I dive in. So, you're doing all that prep work ahead of time instead of saying, I'm a mechanic or I'm not a mechanic. I don't have any skills and I need to fix this car. I'm just going to fix it without any skills. And it's going to be quite the cluster. If you took some time to understand the problem, to work on your skill sets, it's going to be a much easier challenge. But just something to think about there. Okay, so what we can do here is we can look in the logs to see if we find any indication of them utilizing a backdoor. We should see some requests to some files, and then we can start looking for the backdoor file on the system as well. So let's take a peek. What we want to do is put it in order. So when we're looking at attacks, we're looking at them in logical order, and this should be drilled in your brain. I understand what the attacker methodology is, right? So if we look at this, they're brute forcing the login page. What does that mean? They don't have access yet. So initial access is going to fall after all of this brute forcing, which means the backdoor is going to occur at some point after line 359, because this is when the brute forcing stops. Right? Everyone follow me down this rabbit hole here. So it happens sometime after here. And so now we have to look to see if anything looks suspicious. This is where it becomes very difficult and where waters get muddied and people will quickly overlook bad stuff, because a lot of times bad guys aren't as obvious as we make it seem in labs. Bad guys are bad guys for a reason, and they're successful for a reason, right? It's like, why are criminals so fast? Because all the slow ones are in jail, right? You have to be good or you won't be in the business very long. Okay, so let's look through here and see if we see anything. So we know it's a PHP file. We just don't know which one it is. So it's not this one for sure. It's not, well, it could be this one. It could be this one. So we have a lot of, it's not ASPX. You can backdoor that type of file, but it specifically said PHP file. So this is an option. We see this one quite a bit, this one quite a bit, and there's a post there. So there's actually not a ton of logs here for us. One of the other things we can really drill down into is looking at the actual attacker's IP address itself. So this is an IOC we can dig into. So we can just say filter. Oh, didn't allow me to do it. Hang on. Let's try this one more time. There we go. All right, this is going to narrow what we're looking at, maybe help us find something. I will tell you, this is not a super, super obvious answer here, right? So we can see some stuff here, and what we can do is look at all these files themselves if we had to, but we need to move fast. So this is it, not a ton of them. We would need to move fast if this is an active investigation, right? Lots of interesting stuff. I see this WP dash corn more than anything. And let's see what else we see. Admin, we see a theme editor. So theme editor could be used to upload a file. So that's something to think about too. They would have had a way, have to have had a way after they logged into a web application to actually upload the backdoor and execute the backdoor. So there has to be an upload mechanism somewhere, and it's not going to be the login page, probably. So if we take that out of account, this is a really good option, theme editor, to do the upload, and something worth looking at, right? Theme editor here. Theme editor, we see them touching this theme Bloxy. So these are all really good options. All right, so we have some kind of idea here. And what we can do is let's go ahead and jot down our notes here. Um, Brute force, login. And then we'll do, what do we have? Backdoor PHP file. We don't know what that looks like. We'll build this timeline out more once we figure things out. Okay, so let's go over here. Let's go into our SSH session. Now, for those of you who aren't familiar with the command line stuff, we can do a lot of really, really fun stuff in the command line. Let me just move this over so we can chat. And we can do a ton. So we can do some grepping, we can do some catting, we can do some searching, we can do all kinds of stuff. That's the power of the command line. We can do whatever we want to do. So if we say, hey, let's see if this basic command thing is in here, what would that look like? Well, that would look like something along the lines of like doing a find, or we could do a grep for a specific word, something along the lines of, just say grep, and then we can do a tag R for recursive, which means like once we figure out where the web folders are, so first we can search for where's the home directory of the web service, and then we can start looking for files. So we'll actually build two out here. So grep recursive. So once we figure out where the web root is, we'll search everything in there, and then we'll look for command. So it'll be something like, I think we have to encapsulate here like that. And it should be fine. Then we can do some additional work with it in a second. The first command we want to do is we want to do a find, and all we want to find is just any one of these files we want to search for. So the WP login would be a really good one to look at because we know that's what they were brute forcing. That should be where the web application lives. That should point us to the directory. So we can do something like /find, I think it's dash name, and then WP login.php, something like that. And then if we don't want a bunch of errors, what we probably want to do is do this dev null thing. And I'll just copy this out of here because I don't want to type it out. I'll show you the difference between these two. All right, so, and we can ask, if we want to go back in here and ask Google, we can do that as well. We can say, and this is something I encourage you to do until you build up like a list of commands. Just chat with AI to figure out how to do that. Just imagine that you can do anything you set your mind to, like your kindergarten teacher told you, right? How do I find a specific file in Ubuntu? And that's super vague. I should have said like CLI or terminal, something like that. But here we go. Find home name. So this matches exactly pretty much what we have here. And so we can modify this one with our stuff, and I'll show you what it looks like without it. And then you'll be like, oh, this sucks. How do I fix that part? And then we'll fix it iteratively. So you do stuff. All right, so let's paste this in here. And the slash is saying we want to start from the root of the operating system. And we do that because we don't know where it's at. So we want it to just find all the things. So all this permission denied, this is what happens if you don't redirect to null. So we can fix that by just asking, how do I remove all the permission denies from the results? All right. It'll tell us exactly what we have here. And now we have the command I put together. And again, I just pause because I want to show you how you can recreate what I'm doing without me, without my brain, without my background. You can do the same stuff. So notice how much quieter it is, right? We're getting all these permission denied. And these are just, this is what you're going to get if you don't have permissions, right? We don't. We're having an Ubuntu user. We're not running this as root. If we ran it as root, it would check everywhere. But we don't. Instead, we did get exactly what we're looking for, which is a directory var www html WordPress. This makes sense. So let's navigate here, and I'm gonna put this in my notes real quick. I clicked the wrong button there. We'll put it here, and we know what the directory is. So now we'll cd and we just want to look in here first before we do anything so that I can show you how many files there are in here. There's a ton of PHP files. Now, what we want to do is do a grep amongst all these files recursively to see if command appears in anything. Okay, that's next piece here. And again, we can go back over here to say, how do I search all the files in a directory recursively for a specific string? And it's going to pretty much show us the same thing. So this is dot. So this is saying from this directory forward. So we can copy this, put it over here. And we can put in our string. And the reason we chose this string, again, right, is because when we were looking for PHP backdoor, this is what we're seeing. And if we just look up this part, we could look up the whole thing particularly, but I just did this and we can adjust it as we need to. And we'll just throw that right there. All right, so let's throw this in command line, see what we get. And we may get some errors. We may not get some errors. We'll see. Hello, hello. If you're just joining us, welcome. All right, so we do have some results, and we actually only have 2 results. So this looks pretty much exactly what they put here. Let's see if I can do it side by side. Oh, it won't let me. So system, posts, system, get. So this one's a get, but this one's a post. And it's going to be the 404 PHP page. So the question is, did we see any of that? Well, we can come back over here and we can look at 44.php. And we should. Oh, looks like someone else was touching it. Let's see. So we do see, here's a Bloxy file. Here's where they were doing some editing. And then we see some posts. Oh, here we go. I think this is a redirect, or not a redirect, a refer. I think, if I remember correctly. So we do see some of that, but we don't see a ton of interaction. I would expect more interaction, personally, especially if we're looking for them to set up more persistence besides a backdoor. I don't think they will have completely compromised the system in 5 commands. Just saying. unless they're really, really good, much better than me. Maybe they can teach me a few things here. So we do see this. Let's take a peek at the full file now. So let's do a cat of this file and see what it looks like. So here we go. Here's the iSet command system echo. We do see this. This popped up quite a bit. And that's pretty much it. So essentially how these work is that the attacker would just type in the command they want to run and it'll run on the back end of the Linux system. Meaning it's basically mimicking what we're doing in the SSH terminal, except it's a little bit clunkier than that. And typically an attacker is going to move quickly from a web shell to a legitimate shell. Just so you know, and you'll know why. If you ever do any of these offensive rooms, you'll be like, yeah, he's right. Those web shells suck. All right, so we need the absolute path of this PHP file. So, yep, we found it. Now we just need to know the absolute path. And let's see, we could say, we can just type it in here. So we have this. And we can put it in our notebook here. Oh, we already have it there. And then we'll just take this part. All right, so we have the full path here, and now we just need to paste it into here. And my dog may bark momentarily. All right, so that's that one. Hopefully, folks are still following along. You haven't fallen asleep. This is a pretty interesting system, at least I think so. I think it's really good one for people who want to learn how to investigate Linux systems. All right, so which file path allow the attacker to escalate to root? So we have initial access here. We got a brute force login, and then they added a backdoor. They added a theme to the host, which allowed them to get initial access to the actual operating system. So they moved from access to a web application to the back end operating system. And now they have somehow elevated their privileges to root. So now we're looking for that privilege escalation piece. And once they get root, they have all the things. Okay, so a couple of things we want to look at when we're doing this. There's a couple of angles we can do. We can look at, well, we have bash history of different users we can look at, but if this is a web server, they don't actually have a bash history because it's not an account, and we can validate that by just looking at what's in the user home directory. So we can say ls/home. And we can see it's just Ubuntu, it's just TryHackMe. The web server isn't running as any of these accounts. They're probably running under like Apache or something like that. So if we look at cats, Etsy, password, we can see all the accounts in here. Or it could have been running as this, actually. Let's see if there's anything else in here of interest that... Excuse me. So unprofessional, yawning. I don't see Apache on here, so maybe it run as the SEPTA service. Usually there's an Apache account that things are running as. But it's web application most certainly, unless they're completely jacked up, they're not running as a normal user. Okay. All right. So looking at bash history is out of scope here because they don't have one for the account that it's probably running under. But there are other logs in here. And if we go back to old trusty var log, so cd/var log, we should find some other logs that talk about like what types of commands are running on the system, and that would be audits over here. So we do have a bunch, just depends on what it is. We have syslogs here. We have all kind of stuff. And they all have their specific things that they're good for. So just keep that in mind. And it may be worth playing around and looking at these different logs here. So like for instance, if we did tell of off log, we can look and see that there's different cron jobs in here. That's interesting, right? And really, if you don't know what you're looking for, you can just do tell star. Maybe it'll give us tell of all the files. And you can look in here for whatever. That may actually made a mess. But you can look through all the logs. What I'm trying to get at is you can look through all the logs and look for the information that seems applicable to your journey. This is something hunt analysts do as well, where, hey, we're looking for this technique. I don't know where it may present in our security stack. And so their initial task is, what types of logs do we have that allow this type of activity to kind of come through? And their final report may be a smattering of logs they may have never even looked at before. That's just the name of the game here. But let's go to audit, cd audit, ls. So we have one log in here, and if we do tell audit, we can see a bunch of different things in here. What we want to look at is that we can see execution here, which is interesting. So we can see stuff actually being executed. Let me see what the command is. I forgot which one is. How many lines? I want like 50 lines. There it is. In. It was in. Tell dash in. We'll do 30. And we're just looking to see if there's anything interesting in here. Okay. I'm just cat the entire file real quick because this is being a little bizarre. Cat audit. And I think it just got goofed up. CWD. So we are seeing stuff here in here. So user cat var WordPress. Here we go. So this is what we're looking for here. Type equals this. So this is going to actually hold the commands that we want to look for. So let's copy that. That's what we're looking for. And we can just grab. Oops. All right, there we go. All right, so this is what we're looking for here. Sorry, a little bit of a wild ride, but this is them actually executing stuff in the command line, which is important, right? We're talking about how do they get persistent. So in order to navigate on an operating system, they're probably running a bunch of commands maneuvering around. So we see ID, we see print working directory, we see uname. These are all pretty classic signatures of an attack. And what we have here is this is A0 is the first thing, and then every A after that are arguments to it. So this would be sh-c-pwd. This would be uname-a. So this is how you read these types of commands. Now, what we're looking for in here is what is that, backdoor? What allowed them to escalate to root? That's what we're looking at. So we see SOCAT here setting up another command shell. This isn't privilege escalation, right? It asks us privilege escalation. So we don't think they have privilege escalation yet. We keep looking. I don't know what this is exactly. We see bash, we see groups. This is enumeration. So this is one of the things that you should be seeing yourself do as you learn more, is you look at these and figure out what are they doing? What is the attacker doing at this point? And how does it progress their game? How does it how does it help them progress their attack? That's what you should be looking at. And sometimes, right, if you've already done your SOC 1 analyst course and you're looking to continue to add to it, hop over and do an offensive course, and it's going to change your life, I promise. You can hold me to that. It's going to help you look through the eyes of an attacker, I promise. So they're looking for files that they can change, that they're allowed to modify. They're looking for cron jobs that are running. Um, Typically, they're looking for things that are running that they have the ability to modify. And it's a way to do privilege escalation. So they're continuing to look, which means they haven't found anything yet. Now they did run this. So here we see them looking for environments. We see them looking for specific SSH files. That's what I see here. They're doing find. I want to find SSH files that have that I can see. And so we saw them look for ID underscore RSA. Then we see them look for this one. And then we see them cat it, right? A very specific one, because they did a star here. This one is a .back. That means they found one and they put it in there. That's interesting. And then we see them copy this to temp. So this, if you don't know, if you haven't heard of SSH, right, or you haven't set up SSH, if you have the private key and you download it, then you can SSH to wherever you want. So this is a really interesting thing. So let's do something really quick. Let's just take this part. We're going to throw it into AI, and it's going to help explain this to you, because I want you to be able to, again, replicate what I'm doing. What is happening here? And you have to be able to figure out how to get this information quicker. Luckily, you have all this cool stuff. So it's going to tell you, hey, they're doing discovery. They cat and read it. They're moving it to the directory, which is what we talked about. They're fixing permissions on it. And then they attempt to log in as root. So now they're utilizing it to log in as root. That's interesting. So this answers exactly what we were talking about, which is how did they escalate privileges to root? They did it because they found an old SSH key that they had the ability to read. They then made a copy of it so they could execute it, and they elevated their permissions. So we now know exactly what the answer is to our other question. What is the file path? So if we look at these logs, we can say the path is this. Unless they want us to do it in temp. I don't know. We'll see. No, this looks right. And we'll just update our notes here. Found SSH key with read access. Made a copy and elevated permissions with, and then that was right here, SSH. And this is probably what they would consider an LOL, living off the land bin. And we can ask it and see. Explain step 5. So this is what the command looks like. So this says, this is a stealth convenience flag. Normally SSH asks, do you want to connect? So that's what that does. Then it tells SSH to use the temporary key. And that's it. That's really all this does. So you could take this off, but there's this whole thing with interactive shells. So they probably wouldn't have been able to say yes the way they had a connection, whatever. And then they just use the tool. That's it. So that's pretty interesting. I don't know if anyone here watching has seen that before, but it's a pretty nifty trick. Alrighty. So next one is, which IP was port scanned after the privilege escalation? Now we need to think about here is they did privilege escalation. They have logged in as root. Can we see their commands anywhere else? The answer is absolutely we can. Now we have access to bash history because that is actual user with a directory. So let's navigate, and we're going to have to do sudo here, sudo ls, and it's going to be root. We're probably not going to be able to see it without tac la. There we go. And in here, we can see a bunch of things. We have MySQL history, but what we're super excited about is the bash history at the top. So we can say sudo cat root dot bash. Won't let me autocomplete. Sad face. All right, basically this is everything that the user did we can see in here, so we should be able to get an understanding of what they did. Let's see. Here we go. Nano readme keys. So we don't really know where it started. Maybe here. Maybe they set up an SSH key as a backdoor themselves. Maybe. Let's see, killing DeceptiPot. This is getting an IP, but this looks like a loop. This is netcat as well, which is pretty interesting. We also see an SCP, so something we actually did to pull down a file. So this is probably pretty interesting. This is most certainly from this point forward is the attacker. This may be as well, this may be as well, but for sure this. And our question is, which IP was port scanned after privilege escalation? And that will be this guy. They did a handful of ports. And for those of you who don't know, who haven't really done this before, if you don't want to be super loud in an environment, you're going to do a more minimal port scan, right? Most people are used to doing nmap and doing like an all port scan. Yeah, that works in a live environment, but if you're like say doing a red team true adversarial, you're only going to do one or two. You're going to space out the timing. You're going to do a lot more work to minimize the noise, and that's what they did here, just in case you're curious. So we have our next answer. All right, what is the MD5 hash of the malware persistent on the host? So this is the hard part. So the malware persisting on the host. So they have a backdoor in the web server. They have a SOCAT connection, and they are root. But now they're saying they have malware that is persisting on the host. And I think we saw some of that in here as well. Hello, folks. If you're just joining us, feel free to say hello in chat. All right, so we did all this. Let's focus here. So I believe this is where they started doing bad guy stuff. So they look like they pull a file down, they unzipped it, they CD to it, they ls, and they ran it. But this doesn't really tell us exactly what happened. And then they removed everything in the directory. Oh, let me go ahead and mute. The dog is going berserk. 1 second. All right, so we don't know what actually happened. So this is where the fun part occurs is we got to dig in and figure that out. And then they cleaned up their trail behind them. So not only do we not know what happened, but they removed all of that. Removed their whole trail, so we don't know what they did. So this is where the fun part comes in. This is why I thought this was going to be a really good one to demo, is because you actually have to have some creativity to find the answer on this host. All right, so one of the things we can do is that we can start looking to see if we know what the attacker's origin IP is. We can search our logs to see if that pops up anywhere else, like other types of connections, if there's anything making an outbound connection to it. And, and this is pretty common too, right? A lot of times they won't change, or a lot of times they do. A lot of times they use similar infrastructure for every host that's compromised. So these are definitely really good IOCs for you to check, and you should be checking whether or not it is the case because it's quick. 5 seconds. Is it in here? If it is, we're good. And we can run that down. We at least know one bad guy. If it isn't, we gotta keep digging and try to figure something out. So for us, let's do a search. So we know over here, we have a grep command where we can search anything recursively for something, right? In this case, we are going to search for something else, and it's going to be the attacker's IP. Where's the attacker's IP? Well, we have it right here. This is the attacker, not that one. This is the attacker's IP, this one right here. So this is the one that was brute forcing stuff. This is our attacker's IP. So we're going to replace this with this, and then we're going to add that there because we want to redirect it because we don't want to see all the noise. This will create a lot of noise. And so let's do a search now. Let's do a CD / and we'll just paste this in here. So we're just basically looking, is there a log or any document anywhere that's reaching out to our known bad guy? That's what we're doing here. So we'll let that run, and it could take a minute, could take a couple of minutes, and we'll see what's going on here. So it should come back with something. We'll see, but yeah, IOCs are definitely a big thing if you haven't heard of that term. So indicators of compromise. So things like IP, file hashes, file names, usernames, things like that are pretty common in our like cybersecurity world, and it is definitely what we use to do all kind of stuff, right? If we're tracking a particular threat group, IOCs, right, are attributed to them. If we are talking about a specific type of attack or a specific type of incident, IOCs. So it's a pretty big, pretty common world, or pretty common word, pretty common thing. So let's look through here, starting at the top. So these are all the logins we have already seen, right? We already did all this research earlier. Try not to make you seasick. So, okay, so these are all the web logs. We don't care about the web logs. We've already done that. So let's get out of web logs. So you just got to get past all of this. And these right here, right after, these aren't web logs. Look at this. So web logs are here. We looked at these earlier. These are syslogs. So these are system logs. Look at this. So DeceptiPot demo, we have something called kworker, and then we have it's connecting to the malicious IP address, and we see it over and over and over. That's pretty indicative of a backdoor if you've never seen one. Repeated attempts to go out. That is a backdoor. So what we are probably going to, I'm just scanning through the rest to see if there's anything else, and then we see that SOCAT one there. So what we can do is terminate that. We could let it run. I don't know how long it would take to finish searching, some time. But we do have kworker here. Kworker is definitely of interest. So what we can do is the same thing, but with kworker, and see what happens. Where does it come up at? What is it? Because just looking at these, most people don't know, what is this? Is it a service? Is it a program? Is it a file? What is kworker? And we'll just do a search, see if we can't find it. So we should see all these logs we're seeing on the screen right now. They should pop up, but we should also see kworker under other contexts as well. We should see it pop up in other places besides syslog and syslog1. So here we go. Started kworker server. So this right here, this first log, this is interesting, right? So this didn't have our malicious IP in it, which is here because, well, there's no IP in it. But that same name is up here as a service. So we know it is indeed a service. That's interesting. So it's a backdoor, it's persistence. Yeah, service makes sense in this case. A service does exactly those things. So let's take a look at this service. So we can again ask Google, how do I look into a service? How do I find information about a service? How do I get information about a service in Ubuntu? So system CTL. So we'll do this and then we'll just type in kworker, see if it works. Look at all this, lots of stuff here. Go ahead and terminate. Status kworker. We may have to do dot service. We sure don't. All right, there we go. So we see, and why we want to look up a service, because a service is more than just the name. There has to be something behind it, like some sort of binary, right? Some kind of program. And that's what I'm determined to find at this point, right? Where is the program? The program is more than likely malicious, and we have to get that hash anyways. The question is, what is the hash of the file that is being used for persistence? I think something like that, right? Hash of the malware persisting on the host. So we're getting close, right? We know a service is reaching out, but we don't know what file the service is running. We should see that now. Look at this. So loaded etc systemd system worker dot system kworker dot service. Interesting. And then right here we see user sbin kworker. So this is where the actual binary lives. So this is the file that's running. This is the file doing all of these connections. And of course, during a real investigation, we would pull it down, do some malware analysis on it, run it in a lab. There's a lot of stuff we could do with it. In this case, we know it's bad because we know this is the thing running, and now guess what? We just have to hash it. So we'll queue it, then we'll say MD5. I think that's MD5, or is it SHA? MD5. Okay. MD5 sum user sbin kworker. And now we have our hash. How about that? All right. And then we just drop it over here. All right. Now, the next thing is the question of, can you access the DeceptiPot in recovery mode? So first of all, we got to figure out what this DeceptiPot business is, and then we need to figure out how it works to see if we can get it going in recovery mode. I don't know. So let's do another grep to see if we can't find DeceptiPot. My upper lip's itching. Okay. And we probably want to do it by name. There's probably a name somewhere. So let's do that. Gosh, so unprofessional. I think iname does it. I think that's case insensitive. And then we'll do this. Oops. Do this here. Okay. So let's see if we can find this. We should see something pop up, and we do. So we see user bin DeceptiPot. Interesting. And we probably also want star here, because there may be other additional files with it. And we do see some. How about that? sbin DeceptiPots. There should be one more file in here, and I don't know why we don't see it. Ah, I know. So we do need to do this with sudo so we can actually find everything. So let's do this. There we go. So DeceptiPot lives as root. We actually do have root on the system, by the way. So with root, we should be able to see everything. Without root, we were missing this config file. So we do need to see what's in the config file. So let's do a cat of that. Sudo cat. All right. So what we're looking in here for is to figure out how to use this tool because I've never used it before, right? I'm sure no one else here has utilized it either. So we're looking for something related to a recovery key. So recovery mode, recovery key, something to that effect. And if we find it, we'll be good. So here's a password. That's not what we're looking for. Elastic password. That's not what we're looking for. Deployment, recovery key. So this is what we're looking for here. So we'll copy this. We'll put it over here for a second. And now we did find the file here before. So let's run this. So this is the actual binary. Yep, just double checking. So this is the actual binary. And so we want to do something like -H. Usually -H gives us something. And we only have a few options. Daemonize, I don't know, -R string recovery key. Okay, great. That's exactly what we're looking for. -R, and then we want to paste this in. Probably have to put it in quotes. Run that, and hopefully it works. Maybe. And there we go. That is our final flag. Perfect. So we'll throw this in here and then we'll have a talk real quick. Okay. So basically what we have here is, and I want to pull up the shell so we can look at all this other stuff. Don't need this. Okay. So we have they brute force login, they get into the web application, then they uploaded a file, which means they must have either elevated their permissions on the web app or were able to brute force an admin's permissions. So they put that in there. And then they utilize that to get access to the underlying operating system to start doing stuff. When they were in there playing around, they were able to find an unsecured SSH key, so bad permissions there, admin, and then they utilized that in SSH to be able to log in with root. So with that key, they were able to say, I'm now root. Then after that, they pulled down a file with SCP. Then they installed a service, kworker, and this was their backdoor. So this service, the great things about service from an offensive perspective is even when the system reboots, which is the key, right? As an attacker, you want to be able to survive reboot. And with a service, you do just that. When it resets, boom, you get your connection back. Maybe all your other shells die, but you get your connection back. Their backdoor is still there in the web application. So even if you remove this kworker backdoor and you forgot to remove the web backdoor, they're getting right back in, and vice versa. If you just like, oh, they got into my web application, you didn't do any more investigation, they're coming right. They're still in there. You never got rid of them, and they could add a backdoor in the web application again. So this is what I mean by you have to do the full investigation in order to kick the bad guys out, or you're going to be in trouble. You're going to be playing cat and mouse over and over and over and over, and it's going to look like a cartoon. So not that great. So hopefully everyone learned a little something tonight. And if you're watching this as a replay, feel free to ask some questions in the Discord community. Happy to answer those for you.